I'm Dan White. I'm co-founder and CEO of Clean Crop. And together with my co-founding partner, Dan Kavanaugh, we have 25 years of experience working across ag supply chains. I started working in the horticulture industry in Pennsylvania growing up, set up a hard cider operation, but I spent most of my career in emerging markets, finding ways for supply chains to unlock higher value markets for exports. 5 years ago, I met Dan Kavanaugh, then commercial manager for Cargill in East Africa, and he and I started looking for a technology that could address this huge range of supply chain contaminants that were consistently one of the top 3 cost drivers on projects that we worked on. It's been about a year analyzing and reviewing everything from high pressure pasteurization to UV light. Eventually, we met Dr. Kevin Keener, who was then a professor of food science at Iowa State University, a leader in developing cold plasma for food safety technologies. We're impressed by what he had done in the lab and co-founded Clean Crop with him to take his innovations to scale. The problem that we're addressing is massive. Around 30% of food is lost between the farm gate and in consumers in a given year. This food is worth an estimated $1 trillion and can be responsible for up to 7% of greenhouse gas emissions between embedded emissions from production and transportation, as well as methane emissions from waste. These same contaminants are responsible for up to 600 million cases of foodborne illness and nearly 500,000 preventable deaths. And regulators and consumers are waking up to these issues. Regulations are getting stricter around these food safety contaminants. Traceability technologies are getting better, and consumers are rejecting traditional solutions like preservatives and additives. Companies we used to work for and with, like ADM and Cargill, a lot more open to innovation and adoption of novel solutions than they were several years ago. So we solved this issue by commercializing something called cold plasma to industrial scale. So at a very high level, we have a proprietary high voltage reactor system that creates a high voltage energy field. And that is just basically free electrons that are sitting around waiting to be added on to gases that push through there. We have a method for blending a proprietary set of food grade gases that we push through that field, generating ionized gases that we then deploy to food surfaces to remove contaminants. It's broad spectrum, being able to address E. coli, Listeria, Salmonella, a wide range of toxins and yeasts and molds. Within almonds and other tree crops, we've been able to achieve a 65% reduction in aflatoxin, a major food safety and trade cost driver in the almond sector, as well as a 99.9% reduction in molds. We're currently underway validating a salmonella reduction, but we are confident that we'll hit the 4-log requirement by the USDA to become a salmonella pasteurization tool within the next 12 months. And most importantly, as we've looked at this technology, and what really differentiates us from many others in this space is that we are able to do this without leaving any residues or quality impacts on the food. So we can tune these reactive gases to selectively degrade contaminants without degrading the lipids, fats, micronutrients necessary for food safety and quality. Because we have such a broad spectrum application, we can unlock over 30 billion in directly addressable applications that we've already validated at the lab scale with R&D beta customer engagements or through our field pilots with just 2 basic form factors in the hardware. So any low moisture food runs on a vibratory conveyor system. High moisture foods like produce have to run on a regular conveyor belt, but everything else in the core product is the same. As I said, we completed a successful field pilot with our first customer in April of this year. We're on track to be post-revenue with this nutsheller in Q1 of 2022. And within the next 18 months have completed field pilots and are on the way to commercialization in seed germination implications, extended shelf life in meat and seafood, and continued expansion in the nut space. We're targeting 1 gigaton of emissions offsets by 2050, largely through extending shelf life on highly perishable foods, keeping them in the supply chain long enough to reach people's mouths instead of ending up in landfills, and displacing more energy intensive forms of pasteurization, like thermal pasteurization, where we are up to 20 times more energy efficient to achieve the same or similar kill steps. Thank you, and happy to answer any additional questions here.